Okay, so we're just going to continue on with example number 6, interpreting a frequency table. Now, last week we talked about the word frequency, and we even looked it up in a dictionary. We looked it up in a dictionary, and what does the word frequency mean? And frequency means how many times something is occurring or happening. Okay, so that's the word frequency means. It's how many times is something happening. So let's take a look. A recent survey was conducted about how many hats your classmates have. Okay, the frequency table below shows the results of the survey. So number of hats on this column talks about how many hats, and in this column talks about the number of students. So how many times do you see something is happening? So just focusing on this part, people who owns 0 to 3 hats, how many people are in this category? So how many people, what's the frequency? 17. Okay, this one over here, how many people owns 4 to 7 hats? What's the frequency? Is 8, right? So it means 8 people owns between 4 to 7 hats. This one here, number of hats, 8 to 11 hats. Okay, how many are in this category? Number of students, 3. Okay. How many are, next category is 12 to 15 hats, is 1. And then 16 or more is 1, right? So in this particular case, that's our information, that's our data, that's the collected information from these students. So let's take a look. How many students have 16 or more hats? How many students have 16 or more hats? 1. Okay, so we're gonna put 1. 1 student. Okay, so this is how many? 1 students. So 1 student. Letter B. How many students have between 4 to 15 hats? 4 to 15. Well, this one here is 4 to 7, okay, and then 8 to 11, and then 12 to 15. So we are really focusing on from 4 to 15. We're focusing on all these categories, okay? So how many are in that category? All of these things. So we have 8 for this one, 3 for that one, and then another one. So that's going to give us 8 plus 3 plus 1. So that's makes 12. I'm just going to write that down here. 8 plus 3 plus 1 will give us 12 students. Is that okay? Next question. This one's a little bit different because it says here, what percent of students have 0 to 3 hats? What percent? Now they're asking for not how many, not the number of students, but what percentage of students have 0 to 3 hats. So we know that there are 17 people who owns 0 to 13 hats. Okay, but that's not what the question is. But how many percent? So how do we calculate the percent? So 17. 17 out of how many students are in here? 17 out of all of the students that you have in here. How many students are there? So 17 plus 8, 25, plus 3, 28, 29, 30. So 17 out of 30 students. So 17 out of 30 students have 0 to 3 hats. So 17. Okay, so let's calculate that one. 17 out of 30. 0.5 something, right? It's more than 17 divided by 30 is 0.566 repeating. Now, that's not a percent, that's a decimal. So how can we make it into percent? What do we need to do? Times it by 100% to make it 100%. So times it by 100 to make it 100%. So it's going to be approximately 56.67%. Okay, so 17 out of 30 owns a hat between 0 to 3 hats. So we want it in percent. So 17 out of 30 times 100. Okay, let's take a look at letter D. Now that we've seen C, what do you think that is? What percent, okay, what percent of students have between 8 to 15 hats? 8 to 15 hats. So how many have 8 to 15 hats? 8 to 15. So we have 8 to 11 is 3. 12 to 15, that's 1. So that's 4 in total. So it's going to be 4. 4 out of 30. 4 out of 30. That's going to give us our decimal value. Times it by 100 to make it 100 out of 100%. So 4 divided by 30 times 100 to make 100%. And it's 13.33%. 13.33%. Okay. Now this one's a tricky one because we haven't really talked about what is the best type for what information, and we even haven't talked about the circle graph. But anyways, it says here, what type of graph would best represent this data? A bar graph, a histogram, a line graph, or a circle graph? I'll just tell you that this is going to be a histogram. A histogram. Because a histogram, the bottom piece are continuous. Okay? 0 to 3, 4 to 7, 8 to 11, 12 to 15. Okay? So it's a histogram. Okay? That's good. Now we're going to get into example 7. Is that 2? Everybody got that piece? We're going to get into circle graphs. Okay, we're exposed to different kinds of graphs we start off with line graph, then we talked about bar graph, we talked about histogram, now circle graph. Just by the show of hands, who's seen this before? Who's seen somewhere, anywhere, a circle graph before? Nobody? Some people? Yeah? Okay. So let's take a look. Carolyn organizes her monthly expenses in a circle graph. Carolyn has monthly net income of $3,200. Okay? And as you can see, this graph has a title. This is the title of the graph. And then in a graph, there's different categories. I'm just gonna zoom it in a bit because I know it's kind of fuzzy. It's hard to read, but we talked about what are the different categories in here. Can somebody talk about, or what kind of category do you see in this graph?
Food categories.
Food, okay, they talk about food, okay.
Savings categories.
Savings, okay. Rent, ooh, rent. Car, yeah, car payment.
Utilities.
Utilities, and the top part there is a little bit kind of dark. It's entertainment. Okay, so now what else do you notice in here? They're broken up into categories. And what else do you notice about this graph? There's a percent, right? There's a number, percent. 36% for rent, utilities 12, car payments 20, savings 10, food 15, and then entertainment 7. Anything else that you want to talk about this?
Payment is rent is the highest categories.
Okay, so you said rent is the highest percentage. Okay, now if the percent number there is not there, can you still see that the rent takes up a big chunk of her budget? Yeah? Okay. So in this particular case, the percent has something to do how big the slice of the pie is, right? Can
we say that 30% of hundreds?
36% means 36 out of 100, right? So okay, now because we're talking about percent, what do you think? Okay, you don't type it in, but I'm just gonna ask you, what do you think it should add up to? If you add up all of these percent, what do you think it should add up to? 100%. Because 100% talks about all of the amount of money that she has. It's just that it's placed for rent. Some part of her money goes to food, the car, and so on. Okay, so why don't we go ahead? Okay, so we said it should add up to 100%. Why don't let's add this all up and see if it does add up to 100%. It does? Okay, so 36 plus 12 plus 20 plus 10 plus 15 plus 7. It adds up to 100%. Okay?
30%. The rent is 4% more than anything else. If you divide it by 3 in 3 different quarters, comes 32 on each. Savings, food, and entertainment would be 32, and car and payment utilities would be 32.
Oh, okay, okay.
And then still, it doesn't add up with rent because the rent is 36.
Oh, I see. That's an interesting. Because this one you said, this one is 32%, right? And then this is 32%,
Yeah,
and that's 36. Yeah. Yeah.
so there's still 4%.
Still,
more.
yeah. It's a
But-
big
but
chunk.
Overall, but all the rest of them are actually more than the rent.
Mm-hmm. Yeah. Put that together. Like all of
But
these
still
put together.
minusing the savings though, because if you're saving money.
Mhm,
it's not
that's
like
true.
It's totally.
It's not like it's completely gone, right? Yeah,
You
that's
still
right.
have something.
She's
Yeah.
a smart lady.
Mm-hmm.
This
Yeah.
lady is smart.
Yeah. It's like saving up a portion of it. Okay. Now, let's take a look at this one. Let's answer some questions. It says here, what percent of her monthly income does she spend on rent? What percent does she spend on rent? 36. So that was easy, right? 36%, because it says there, rent, 36%. That one's not bad, right? Let's take a look. Letter B. What percent of her monthly income does she spend on food?
15%.
What percent does she spend on food? 15%, yeah. That one's not bad because as you can see, it says food, 15%. Right? Good. Now, letter C. This is interesting. How much does she save monthly? Now, it's not what percent, talking about how much. How much? Well, let's take a look. We know her savings is, I'm going to switch back up here. Her savings is 10%. So it means 10% of her income goes to savings. So 10% of her income goes to savings. Okay. Do you remember last time the word of represent mathematically? Multiplication. So 10% of income. Okay. Well, we know 10% means 10 out of 100, right? That's what 10% mean. The word of means times. Income. Well, how much is her income? 3,200. Okay, so 10% of her income goes to savings. So 10% means 10 out of 100 times 3,200. So let's take a look. How much is that one? 10 divided by 100 times 3,200. Oh, wow. She puts away $320.
Nice.
$320 a month. That's quite a big. Huh?
That's pretty cheap
Is it?
compared to what we pay for our rent.
Oh, that's for her
All of that
savings. Yeah.
I'm sorry.
Yeah. Like she saved $320 every month. That's, yeah. Okay. Well, actually, I think you're just reading ahead. You're in letter E. Okay. Let's take a look at letter D. Look at the question. How much does she spend on her car payment? How much? Well, when you look at the car payment, it says 20%, right? 20% of her income goes to her car payment. Okay, so how do we do that? 20% means 20 out of 100 times income, 3,200, 640. $640. So, wow. Well, I hope that car payment includes gas and auto pack and car payment, because that's maybe yeah, that's pretty high. 640.
That's gotta be a
Unless
truck or a Jeep.
yeah, probably. But then over here, she doesn't have gas, auto pack. So I'm thinking maybe it's lump sum to car. Anything that's car related payments. Yeah. Because utilities, when you think about utilities, I'm thinking heat, water, electricity, right? Maybe cable, maybe internet, bills. Okay. Now I think this is your question. The rent.
It is super high.
How much does she pay on rent? Okay, well, how much is a rent? We know it's 36% of income goes to rent. Okay, so let's calculate that. We don't want the percent, we want how much, the money. So 36 out of 100 times, how much is her income? 3,200. Okay, let's see this. It's gonna be a lot.
$1,152.
Oh man.
I'll say that's gotta be the 11th floor.
Must be a big ass house.
1152.
Unless she's a politician.
Okay, maybe this rent includes in her rent other stuff. Maybe it's a big house. Maybe it's a house. Yeah. Okay, 1152. Okay, so that concludes everything that we talked about in terms of graphs. So we talked about line graphs, we talked about bar graphs, we talked about circle graph and histogram. Okay, so what we're gonna do at this particular time, okay, as you can see, there's an assignment 1. So there's an assignment 1 that follows. You can work on your own, you can work with a buddy, you can work with a group, but this is what we're gonna be working on for today, okay, for the rest of the morning.